So we want to evaluate these definite integrals, and there's another one just over here, part of the same example. Now, note that I'm not talking about them, or I haven't asked the question in terms of area, but I want to relate these to area, and that's the whole point of doing this actually. So x cubed looks something like this. It's actually completely flat at the origin, but it doesn't matter from the point of view of what we're discussing. And the integral from 0 to 2 of x cubed could be related to this bit of area just here. So let's do the integral. So we integrate x cubed, we get x to the 4 over 4, and we want to evaluate that from 0 to 2. So 2 to the 4 is 16, divided by 4 is 4. When you substitute 0 in, you just get 0. So we're going to say that that's 4. And we won't worry about the square units because we weren't asked for that in the question. But a reminder is I'm relating to that. Now, if we look at x cubed this time from -2 to 0, we must be talking about this area just here. So the integral is the same, x to the 4 over 4 from -2 to 0. So using the top limit we get 0. Using the bottom limit we're going to get -2 to the 4, which is 16, divided by 4, which is 4. So we end up with -4. Now, by symmetry, you'd expect the two areas to be the same, and indeed they are. So why is this one a negative? Well, it all comes down to the fact that this area is below the axis, and this is above. Remember that I've already mentioned that we talk about a y and dx. Well, if it's below the axis, the y is negative. So let's go to the last part of this example and do this integral. So that's going to be x to the 4 over 4 from -2 to 2. So that's going to be 16 over 4. Take away, well, -2 to the 4 is also 16. 16 over 4, which is 0. Now, clearly, the area that we're talking about is not 0. We can see the area. But what's happened is that this one came out as negative, this one came out as positive, and they were exactly the same numerical value in modulus, and they've cancelled each other out to give us this 0. So when we get an area to work out where some of it's below the axis and some of it's above the axis, we have to work them out separately so we don't get this cancelling out effect. And that's the point of the example I've just done. So the lesson of this last example is that we have to be careful if parts of the graph are below the x-axis.